As we begin our new year of AP Chemistry, I'm excited, as I hope you are. We're going to start this year out with a unit that deals with a very lab-based type of calculation called gravimetric analysis. We do different kinds of laboratory tests and things with different substances and mixtures of substances, and using the information from the masses of substances involved, etc., we can make determinations about purity of substances, about how much of a substance is in a mixture, lots of different things that we can do with it. And all of the notes in this unit are designed to give us the tools that we need to do those kinds of calculations. Now, if you are skipping, or if you did skip a year between pre-AP and AP, it may be a little bit difficult to get back into the swing of things and to remind yourself of some different types of calculations. But remember, you have a lot of resources on the pre-AP page. There are notes, keys still up for all of the units, and as the summer is going, as the summer progresses, I'm going to be doing and building the video notes files that are on the pre-AP website, and you'll be able to access those as well if you get to an area that you really feel like you're really weak on and you don't remember. So anyway, that just reminds you that there are some places out there to get some help if you feel like you're struggling a little bit with something. So let's look at this first type of calculation, and it's the mole fraction. Now, mole fraction is really just percent without the times 100. So you can kind of think of it like that. Percent without times 100. It's a lot easier to use in calculations because we don't have to sit around and worry about whether we need to divide by 100, multiply by 100, whatever. It has the same type of equation that percent does. It's partial over total, again, just without the times 100. So if we look for the mole fraction of something, and mole fraction, handwritten, looks kind of like a curly QX. Mole fraction is the moles of whatever substance that we're targeting, and we're dividing that by total moles. Be real careful because it's really easy to put moles of one substance divided by moles of the other substance. But we're not doing partial over other partial, we're doing partial over total. So let's look at this first example. The first example says that we're supposed to determine the mole fraction of iodine. We're going to use the same attack methods that we used in pre-AP of circling what we're trying to find and underlining the other pieces of information. It gives us, in this case, that a mixture of iodine and carbon tetrachloride. It tells us we have 0.23 moles of iodine and 1.1 moles of carbon tetrachloride. So let's look at our equation. We're trying to find mole fraction of iodine. Remember, iodine's diatomic. Won't really matter in this particular problem, but we just want to remind ourselves of some of those pre-AP things. So iodine mole fraction is going to be equal to the moles of iodine divided by the moles of iodine again and carbon tetrachloride. So we've got partial over total without the times 100, so let's plug those values in. The mole fraction of iodine is equal to 0.23 moles of iodine that it gives us in the problem, divided by our 1.1 moles of carbon tetrachloride and our 0.23 moles of iodine again. So what we end up with there is 0.23 moles divided by 1.33 moles, and we end up with a mole fraction of iodine then equal to 0.17, and notice that the moles cancel. We have no units on mole fraction. That's not very common in chemistry, but this is one area where we don't have units on a value for once. Mole fraction is unitless, so that's the mole fraction for iodine. So let's look at one that's a little bit more complex. Let's look at this next one, and in the next one, notice the difference. It says a canister contains 2.3 grams of phosphorus pentachloride, 1.2 grams of phosphorus trichloride, and 0.75 grams of chlorine, and we're supposed to find the mole fraction of each of these gases. Hopefully you've noticed that the difference is it didn't give us moles this time, it gave us grams. So what we're going to have to do first is to change these mass values to moles. So let's do that side calculation first before we even write anything else down, because we know we've got to do it anyway. So we start first of all with 2.3 grams of PCl5, phosphorus pentachloride, and we're going to use the conversion factor, the molar mass conversion factor. If we add up phosphorus and 5 chlorines from the periodic table, we get 208.22 grams per mole of phosphorus pentachloride, reminding us of those mole mass conversions that we've done before. We end up with 0.01105 moles. Now, I'm not worried about sig figs at this point. If anything, I want to overdo the sig figs so that I don't have any weird rounding errors at the end. So there's the moles of PCl5. And let's look at PCl3. We've got 1.2 grams of PCl3. If we add up 1 phosphorus and 3 chlorines, we get that a mole of this has a mass of 137.32 grams. When we divide that out, we end up with 0.00874 moles. And then finally, our last one is chlorine. Said we had 0.75 grams of chlorine. And if we add up chlorine, we get 1 mole equaling 70.90 grams. And we have a value of 0.01058 moles of chlorine. So those are our mole values. And now we simply need to do a calculation for each one of these to get our mole fraction. So our first one, PCl5, the mole fraction of PCl5 is going to be the moles of PCl5 divided by the moles of PCl5 plus the moles of PCl3 plus the moles of Cl2, all of the moles. And we won't have to write this out every single time, but we are going to for this first one. And as it shows up there, we have a value for moles of PCl5 of 0.01105 moles. And on bottom we have 0.01105 moles plus 0, and I hope I don't run out of room, I'm going to write really small, 874 moles, and 0.01058 moles. Made it. When I work this out, I get that the mole fraction then of PCl5 is 0.0115 moles divided by the total, which is 0.03038 moles. And I get a value for the mole fraction of PCl5 of 0.36. So there's my first mole fraction. Now for the rest of the mole fractions, since I already know the total on the bottom, that's not going to change. So all I'm going to need to change to get the rest of the mole fractions is simply the top number. So when I look at the mole fraction of PCl3, that is simply going to be our 0.00874 moles of PCl3 divided by the total, 0.03038 moles. And I get a mole fraction for PCl3, phosphorus trichloride, of 0.29. And finally for chlorine, the moles of chlorine were 0.01058 moles divided by the total once again, 0.03038. And I get a mole fraction for chlorine of 0.35 moles. Now, if you're asked, as this one did, to find the mole fraction of each substance involved, notice what the values add up to. That's a good double check. If you add up the 0.36 and the 0.29 and the 0.35, you end up with 1.00, just as you would with percentages adding up to a total of 100%. So again, a good double check for you.